Have you ever asked a chatbot a question or used an app to create a picture with just a few words? That's the magic of artificial intelligence, or AI. But behind the scenes, every AI interaction uses a surprising amount of electricity. That power comes from the grid, a vast network of power plants and wires that keeps our world running. The digital revolution is built on a foundation of energy. AI is the next big leap, and it's incredibly power-hungry. The computers running AI aren't like your laptop. They're massive clusters in giant data centers, consuming electricity on a scale that's hard to imagine. As AI becomes more capable, we use it for more things: research, healthcare, entertainment, and more. Each task requires immense computational effort, and every calculation needs electricity. As the AI boom grows, so does its appetite for energy. This isn't just a tech company problem, it's a challenge for everyone who shares the grid. The future of AI and the future of our energy are now inseparable. Can our aging electrical grid keep up with AI's explosive growth? The answer will shape our future in ways we're only beginning to understand. Let's dive into the science behind this digital hunger. The story starts with why AI is different. You might wonder, what makes AI so different from regular computing? It's all about intensity and scale. Training a large AI model is like lifting a building, not a dumbbell. Servers process trillions of data points for weeks, generating enormous heat and demanding huge amounts of electricity. And it doesn't stop after training. Every time you use AI, it's running, a process called inference. Billions of requests happen daily, creating a constant, high-level demand for power. Unlike factories that shut down at night, AI data centers are always on. Some experts predict AI could soon consume as much electricity as entire countries. Traditional industries grew slowly, but AI's demand is exploding in just a few years. This creates intense, localized pressure on the grid where data centers cluster. AI's energy demand is unique, intense, constant, and growing at breakneck speed. It's not just another app, it's a fundamental shift in how we use computation. Meeting this demand means rethinking how we generate and distribute electricity. We need a new kind of plan. Our electrical grid is a marvel, but it moves at the speed of steel and regulation. Building new power plants or transmission lines can take a decade or more. Meanwhile, tech companies can develop new AI models or build data centers in just a couple of years. This mismatch creates a serious bottleneck. Utilities get sudden requests for power equal to a small city, but their plans can't keep up. The result? Delays, grid strain, and even blackouts. This isn't hypothetical. It's happening now in places like Virginia and Arizona. Utilities are scrambling, sometimes delaying the retirement of old polluting plants. The slow pace of grid planning is being overwhelmed by the rapid demands of AI. We need to bridge this gap before it threatens our energy security and climate goals. So, how do we keep up? The obvious answer is to build more capacity, more power plants and more transmission lines. For years this meant natural gas plants, which can ramp up quickly to meet demand. But relying on fossil fuels isn't sustainable in a world fighting climate change. We need to add new capacity in a way that's clean and responsible. Simply firing up more fossil plants would undermine our environmental goals. Beyond generation, we need stronger transmission lines, the superhighways for electricity. Without them, even the biggest power plant can't deliver energy where it's needed. Building this infrastructure takes time, money, and coordination between tech, utilities, and regulators. There's no single solution, it's a complex puzzle. We need a multi-pronged approach, more power, smarter power, and a more robust grid. Building new capacity is just the beginning. The real challenge is making it clean, reliable, and ready for the digital future. So, what kind of power should we build? Let's look at renewables. The AI boom is a chance to accelerate our shift to clean, renewable energy. Solar and wind are getting cheaper and more efficient every year. AI's massive demand could drive investment in huge new solar and wind projects. Renewables have a big advantage. Their fuel is free, and they don't emit greenhouse gases. Imagine solar arrays and wind farms powering the AI that's solving global challenges. But renewables face a challenge. The sun doesn't always shine, and the wind doesn't always blow. AI data centers need constant, reliable power. The answer? Energy storage. Giant batteries and other solutions to store and release power as needed. Pairing renewables with storage is key to powering AI cleanly. Many tech companies are already leading the way, signing huge renewable energy deals. Powering AI with clean energy helps us meet both our digital and climate goals, but efficiency matters too. We can't just build our way out. We need to use energy smarter. Energy efficiency is crucial. The best watt is the one you never use. AI hardware is evolving. New chips are more powerful and more efficient. Designers are squeezing more calculations out of every watt. It's like upgrading from a gas guzzler to a hybrid. Data centers are also getting smarter about cooling, using outside air or liquid systems to cut waste. Some are even built in cold climates for free cooling. Innovative designs and smarter operations can dramatically reduce wasted energy. Efficiency improvements ease the burden on the grid and help us meet demand sustainably. Every step toward efficiency makes powering AI more manageable, but hardware is only half the story. Software matters too. Let's see how coding can cool the planet. Software plays a massive role in AI's energy use. Efficient code can save as much power as efficient hardware. Researchers are making AI models smaller and more streamlined, using techniques like pruning and quantization. Smarter algorithms mean less brute force, more elegance. Some models only activate the parts needed for a specific task, saving energy. This focus on efficiency is creating a new field, green AI. Developers now measure and report the energy footprint of their models. Competing on efficiency, not just accuracy, is the new frontier. Smarter code means less energy wasted and a cooler planet. But the impact of AI's energy appetite goes far beyond the data center. The energy demands of AI ripple out to affect everyone. Massive data centers constrain local grids, risking reliability and raising prices for all customers. If utilities can't keep up, it can slow progress toward clean energy goals. Old fossil plants may stay online longer, undermining climate targets. The competition for power can squeeze out other businesses and slow economic growth. Some regions already warn they can't support new industries because data centers use all available capacity. The AI boom could unintentionally slow development in other sectors. Making the grid resilient is about more than just servers. It's about stable, affordable, clean energy for all. Our choices now will shape whether AI's benefits are shared widely or come at a cost. Powering AI is a societal challenge, not just a technical one. So how do we move forward together? Can the grid survive the AI boom? Yes, but only if we work together. The future of AI isn't just written in code. It's built by engineers, utility workers, and policymakers. We must recognize the deep connection between the digital and physical worlds. Collaboration is key. Tech companies need to be transparent about energy needs. Utilities must innovate, and governments should streamline essential projects. Innovation will be our greatest ally. More efficient chips, smarter software, better data centers, and cleaner energy. AI itself can help, optimizing grids and predicting demand. This is about more than keeping the lights on for tech giants. It's about our collective future. We face a choice. Let AI strain our grid and climate, or use this moment to build a cleaner, smarter, more resilient energy system. The future of AI depends on responsible energy planning. Our energy future can be brighter with the promise of AI. Let's seize this opportunity. Let's build a future where technology and sustainability go hand in hand. The work starts now. Let's get to it.